Hi everybody, my name is Cameron and today we're going to be looking at chemical calculations, so specifically our molar calculations when it comes to chemistry. Okay, so as we do this, I would suggest taking down some notes. Okay, and by notes I mean the pyramids. Okay, there will be I think 3 pyramids that we are going to be looking at today, and if you can remember these pyramids and some of the steps I tell you to do molar calculations, you'll be fine with most of the questions they can give you an exam. Okay, so the first calculation or concept that we have to understand is what relative mass is. Okay, so the relative atomic mass, because we can't actually measure on a scale or something the mass of an atom. Okay, we can't put it into units of grams, even nanograms. Okay, so we use these mass units that we've come up with. Okay, and they're based off the carbon 12 atom. Now, carbon 12 meaning that the mass number is 12. Okay, so it has 6 protons and 6 neutrons. If you remember from our first video, the mass number is equal to the protons plus the neutrons. Okay, so when we're talking about the relative atomic mass of an element, what happens is we have to take into consideration the isotopes of that element. Okay, if you remember, isotopes are when they have the same amount of protons, because it's the same element, but different amounts of neutrons. Okay, so how can you have one relative atomic mass number for an element? Okay, you're going to take the average mass for all the isotopes. Okay, and that's why we don't see the isotopes on the periodic table, but we do see mass numbers that have decimals in them. Okay, it's because they're averages. And when we look at our number of moles, okay, now the number of moles is going to be extremely high, so we have calculated this average constant called Avogadro's constant of 6.02 times 10 to the 23 atoms per mole. So we work out the number of moles, we times it by that constant, okay, and that's going to give us the end value or the number of atoms in that mole. Okay, so our first pyramid. Now I want this to be on your bathroom mirror. I want this to be on the ceiling of your bed, so it's the last thing you look at before you go to sleep. Okay, these pyramids are going to be summaries of the calculations that you're going to use. Okay, so it also allows you to manipulate these equations a lot easier. So on the top of our pyramid we have M, which is the mass of atoms in grams. Okay, then at the bottom we're going to have our number of moles. Okay, and then the capital M is going to be our molar mass or relative atomic mass. Okay, and that's going to be in grams per mole. So when it comes to, and we'll do some examples of these, when it comes to our number of moles, okay, we're going to use the number of moles to find the limiting reactants. Okay, so when we find limiting reactants, we're going to calculate the number of moles and then see which one is the lowest. It can also be used to find the number of moles of other atoms because it's all going to be a ratio. Okay, we'll get to this as well. When it comes to the molar mass, okay, it's affected by the number of atoms in a molecule as well. So those small little numbers, okay, that we see next to atoms that tell us how many atoms there are, those count as part of our molar mass, okay, for a molecule. But write this pyramid down. You must remember it. So small m over number of moles multiplied by our molar mass. Okay, so let me see if I can draw it here. This line represents a multiply. So if we're going to want n, it's going to equal to our moles in grams over our molar mass. Okay, if we want to find out what the grams of our substance is, it's going to be our number of moles multiplied by our molar mass. So when it comes to calculating these equations, the steps that I always tell my students are as follows. Step 1 is to write out your equation. Okay, balance it if it needs balancing as well. Step 2 is to write under each molecule what you know about it. What have they given you? What have they told you about it? Okay. If they've given you the mass in grams, if they've given you our moles, you're going to write there M equals and your mass in grams underneath that molecule. Okay. Then usually what they'll do is they can give you the atomic mass, but if they don't give you the atomic mass, then work out the atomic mass for the molecule that you were given information about. Then what you're going to do is you're going to find out what are they asking for. Are they asking for the mass in grams of a certain product? Are they asking for how much of the reactant to use? Okay, and next to that molecule that they're talking about, you're going to write, let's say, the number of moles, N equals question mark. Okay, so you want to keep track of exactly what you've been given and what you need to find out. Then with this information, you're just going to calculate whatever you can. Even if you don't understand the question, preferably you want to understand it, but even if you can't, calculate whatever you can. Write down what it is you have calculated with the symbols, and then figure out how to get from that to what you need. Okay, a lot of the time what's going to happen is they're going to give you enough information to calculate the number of moles, so the N value, okay, of one substance. Then depending on this ratio, you're going to be able to calculate the N value of another molecule. Okay, so in this case we were given 100 grams of sodium hydroxide. What we can do is we can calculate what is the atomic mass of sodium hydroxide. We can find the number of moles of sodium hydroxide then, and because the ratio is going to be 2 to 1, we can divide that number of moles by 2 to get the number of moles of chlorine. Once we have the number of moles of chlorine, we can then calculate the mass using our molar mass. Okay, and remember, your molar mass can be obtained from the periodic table. So if we were to be given the masses, okay, of the reactants and the products, how would we calculate a balanced equation from that? Okay, so we would also know the atomic mass of each molecule. We could calculate that. We're then going to find the number of moles of each chemical, each molecule. With those number of moles, as I said before, you can calculate them using a ratio. Okay? And once we find the ratio, that will then indicate how many molecules there are of each chemical. Now, number of moles, okay, the moles, M-O-L-S, and the number of molecules are different things. The coefficient number is not the number of moles. Okay, the molar number is going to be calculated number using the mass numbers. Okay, but their ratio, the ratio of moles, can give us how many molecules of each molecule there are. Okay, so as we can see in here, we have been given our mass numbers. Okay, we calculate our atomic masses, and okay, so in this case what we want to do is we want to find the mass of oxygen. Okay, so because of the law of conservation of matter, we know that if there is 8.5 grams of matter going in, there must be 8.5 coming out, and therefore 8.5 minus 6.9 is going to give us what is still required of our products to equal the total mass of matter that we had in our reactants. Once we find our mass number, we can then calculate the number of moles, N value, okay, of each molecule, and then we're going to look at the ratio. Okay, so this is going to be a ratio of 2 to 2 to 1. because this is going to be our 1. This multiplied by 2, okay, is going to give us 0.1 and 0.1. So it's a 2 to 2 to 1 ratio. And that's going to be our balanced equation. Okay, it's going to be 2 sodium nitrates giving us 2 sodium nitrites plus 1 oxygen. Okay, and again, this pyramid should be drawn at the top of every page. There's another pyramid coming up later that we're going to need to know. Okay, so now when it comes to calculating limiting reactants, we're going to be using again the number of moles to figure out which one is the limiting reactant. Now, limiting reactant is going to be something that will be used up first. Okay, then that means that the other reactant is going to be in excess, while the one that finishes first is going to be the limiting reactant. Okay, and it's not always as obvious as saying, well, the one with more mass, right? Because in this equation here, we can see that we have 40 kilograms of titanium chloride and 20 kilograms of sodium. You might think, of course, the sodium is going to run out first. But in fact, if we calculate the number of moles for each one, we find that the sodium actually has more moles than the titanium chloride, which means the titanium chloride will be used up first. Okay, and then therefore it's going to be the limiting reactant. So again, use the steps that I say. You must first write down your equation, then underneath it you can write down what you've been given. We've been given our M value, a small m, the mass in grams of titanium chloride, and then the small m of sodium. Okay, you're going to write those down. You're then going to put the mass numbers under both of those. You're then going to be, they then ask, okay, which one's the limiting reactant? At this point, you're just going to use those values you've been given and what you've worked out from the periodic table to calculate the number of moles. It's as simple as that. You don't even have to understand the question here to still get marks for it. Write down what you've been given, write down what you can find out, calculate whatever you can. And then go look at the question and see what it is they need. Or rather, see what it is they need, and then if you still don't know, calculate whatever you can. Okay. But read those questions in full, write out everything in the question using the symbols you've been taught. Okay? And then just do your calculations. Okay, another calculation that they love to ask in these tests is the percentage yield. Okay, so it's all good and well for us to be doing these calculations and say, oh, I have been given the mass of the product and I can now find out how much, or I've been given the mass of the reactant and I can now find out the mass of the product that it will be made. Okay, those calculations are great and it'll be somewhere around there, maybe, but it's not going to be always that accurate. Okay, so there are some things in reality that will make the product be less. Okay, mass will be conserved, but not in our equation, because it's not always going to be a closed system. Okay, so some of the reactants could escape into the air if a gas is produced. Some of them could be left on our apparatus, on the beaker sides, or on the spoon that we use. Okay, sometimes a reversible reaction can take place where some of your product goes back into being a reactant. Okay, so the percentage yield is how much are we actually going to make divided by how much we thought we were going to make multiplied by 100. And you'll probably find that will give you a percentage, because it's never going to be exactly, or very rarely will it be exactly 100%. Okay, it's going to be a percentage. So your actual yield, which is what they will give you in the question, they'll give you the actual yield, ask you to calculate the theoretical yield. Or what they can do is they can give you the percentage yield and ask you to calculate the actual yield, or vice versa. So this just comes down to manipulation of that calculation. Again, just write down what they have given you below the question, okay, so that you can have a clear understanding of what you've been given and then use the formulas that you have and the information you have to calculate whatever you can, okay. Specifically with percentage yield, the actual yield and theoretical yield are going to be the mass in grams. That's what we're trying to calculate when we try to figure out the percentage yield. Okay, so percentage economy is pretty similar to our percentage yield, but instead what we're looking at here is how effective is the equation in making a specific product. A lot of the times with the equations we use or the chemical reactions we use, we're going to get a waste product, a product that we don't actually want. Okay, so the percentage economy is going to find out what is the percentage economy for a specific chemical reaction. How efficient is it at making our specific desired product? Okay, what we use here is the relative atomic mass. So we're going to take the relative atomic mass of the desired product of that one molecule divided by the total mass of the reactants, the starting materials, multiplied by 100. Okay. What they can also say sometimes is that if there is a use for the waste product, then that is going to increase the percentage economy. You see, because now there is no waste that we have to dispose of or treat. Okay, it becomes another product that we can either make money of or use in the reaction again. Okay, some chemicals are like that. So here's an example of atom economy. We're going to be calculating the percentage atom economy of the production of silver iodide in this reaction. Okay, so silver iodide is going to be our desired product, and this sodium nitrate is going to be our waste product, you see. So we're going to then calculate the relative formula or relative atomic masses for all of our molecules, okay? Even though we don't really need sodium nitrates one, but we still have it, okay? The total mass of our reactants, okay, is going to be 170 plus 150, which is 320. That goes to the bottom, okay? And then the atomic mass of our product, our desired product, is 235. So 235 divided by 320 multiplied by 100. The percentage economy is then going to be 73.4%. See, easy enough. Okay, so the next set of pyramids that you are going to be sticking to your head and seeing before you go to sleep in the days before your test are for concentration. Now, what is concentration? Concentration is how much of a solute you have put inside a solvent. Okay, solvent is going to be the liquid. Solute is usually the solid that you're going to dissolve inside your solvent. Okay, how to remember that? I like to remember solvent. The V kind of looks like a W for water. So water is going to be your solvent, and what you use is the solute. Okay, the salt, let's say. So concentration is how much salt there is inside of your water, let's say. How much solute is in the solvent. Okay, so it's measured in grams per decimeters cubed or moles per decimeters cubed. Now decimeters cubed is the unit we use for volume. Okay, so if we are given centimeters cubed, you're going to divide it by 1,000 to get to decimeters cubed. If you're given liters, it equals to decimeters cubed as well. Okay, that's important to remember. A lot of the times in these tests, they're going to give it to you in centimeters cubed, and you are expected to divide it by 1,000 first before doing the calculations. After that, it's just a factor of remembering these pyramids. Okay, so the first is N over CV. Okay, that's if we're working with moles per decimeter cubed, or we can use M over CV. Okay, that's if we're using grams per decimeter cubed. You can use either one of these. Okay, you can also merge them into one pyramid if you want, and just go N/M. if you're going to remember that you have to choose one of those. Okay, and it's as easy as that. Okay, so this is just, if you have to write down these 3 pyramids, or even 2 pyramids, if you can merge these 2 together, then you'll be fine for calculations. Okay, you follow the same steps. You have to just write down what they have given you, okay, with the symbols. Okay, you're going to do your conversions. If it's a volume and it's in centimeters cubed, you're going to put it in decimeters cubed. If it's in kilograms, you're going to put it into grams. Okay, and then you're going to calculate what you need or whatever you can. Okay, so let's do an example of a concentration calculation. Okay, so most of the time the concentration equations are going to be for titrations. Now, what is a titration? A titration is when we try to find the end point. Okay, the end point being the point at which our acid is neutralized by our base. Okay, so we start out with our acid at the bottom in a conical flask, and we're going to slowly add our base. Okay, and eventually it's going to be neutralized at a certain volume. Okay, so as you can see here, the titration is the process used to find the exact amounts of acid required to neutralize, or acid and base to neutralize one another. Okay, so again, if the acid is going to be in excess, it's going to obviously be acidic. If the base is in excess, it's going to be basic or alkaline. Okay, and it's a neutralizing reaction. It's going to form salts. Okay, so if you use something like hydrogen chloride and the base be sodium hydroxide, it's going to form sodium chloride, and you're going to have water being created as well. Okay. Again, write down these pyramids, practice a lot of these examples. Okay, you don't even have to practice a lot of them, you just have to get used to doing the steps. List what you've been given, and then you are going to, or list what you've been given with the formula symbols, then you're going to see what it is they're asking of you, calculate that, or if you don't know, calculate whatever you can. Okay, just make sure that your volume is in decimeters cubed, your mass is in grams, and you'll be fine. Okay, there is questions for titrations on Moodle, so give that a go if you feel comfortable with this, and best of luck for your test. You'll be fine when it comes to calculations. Take it easy, work through it, make sure you do your conversions, remember your pyramids, and the best of luck. I'll see you in the next lesson.